Hello students, for math analysis I decided to make a video answer key for this night's homework just because sometimes reading all these steps can be confusing on one's own. I think number one here of the three problems, number one, the algebra is what's most challenging. Number two and three, it's just the intervals that are a little bit tricky. But again, if you have a calculator, you can just type in the functions in y equals along with the interval in the window to know at least how many solutions you'll have. They won't tell you the solutions themselves, but you can figure out how many you should end up with. So that could be helpful. All right, number one, we have 3 cosine times cosecant equals 2 sine. And what I first did was because there's so many different kinds of trig functions, I first decided just to write all of them, at least in terms of sine and cosine. That's always a good first line of business, to write cosecant in this case in terms of 1 over sine. And then you have 3 cosine times 1 over sine. That becomes, on the left-hand side, 3 cosine over sine, where my finger is, 3 cosine over sine, equals 2 sine theta. Then I multiplied both sides by sine theta to get rid of the fraction. So the left-hand side just becomes 3 cosine theta. The right-hand side becomes 2 sine squared theta. All right, so I'm right here now. Now that you have 3 cosine equals 2 sine squared, I then replace the sine squared with 1 minus cosine squared, right? The Pythagorean identity that allows us to substitute 1 minus cos squared for sine squared. Now that we're here, we have an equation with just one type of trig function, cosine. All right, distribute the 2, get all of the values on one side because you're solving a quadratic. So you want to be factoring, right? So I brought all the terms to the left-hand side because I wanted to work with a positive lead coefficient. Always a good idea. 2 cosine squared plus 3 cosine minus 2 equals 0. Factor that like you know how to factor a trinomial. You get 2 cosine minus 1 times cosine plus 2 equals 0. Just to go back here, guys, from this point you might have used u substitution. Let u equal cosine theta. If that's a little more manageable for you, that's fine. Okay, I didn't do that. And now you have the problem factored. So you have, okay, 2 cosine minus 1 equals 0 or cosine plus 2 equals 0. So that means that cosine is either positive 1/2 or negative 2. Well, here are those two values, right? Cosine is positive 1/2. Solving that using the unit circle values we get pi over 3 and 5 pi over 3. Cosine is never negative 2, right? The x value on the unit circle is what cosine is. That is always between negative 1 and 1. So there's no solution to that part, but there are solutions to this part. We get those two as the final solution. All right? Long problem, a lot of algebra. Okay, so those are a little challenging, but again, first line of business, write everything in terms of sine and cosine, and eventually whittle that down to just cosine with this problem. All right? Second one, we have just a 4 sine squared minus 2 equals 0. There's only one trig term there, so just get it by itself. Solving for sine theta, I would add 2, divide by 4, so you get 1/2. So sine squared equals 1/2. Now, you would square root both sides. The square root of 1/2. Well, the square root of 1/2, the square root of 1 is 1, the square root of 2 is 2. And if you rationalize the denominator there, you get root 2 over 2. Okay, so the square root of 1/2 actually is root 2 over 2. Always keep that in mind, all right? So we have plus or minus root 2 over 2 because we square rooted to solve, all right? So all we have to do now is figure out, okay, where on the unit circle, what reference angle has a sine of root 2 over 2? It's all the 45 degrees. So this happens at all of the references of 45 degrees. 45, 135, 225, 315. And we keep going until we've gone too high for the interval. So the interval was 0 to 540. So we keep going, after one way around, 360 plus 45, we're at 405. And then the next one will be 495, okay? Kind of like adding the period like we did before. The period, if it's just theta, if the angle is just theta, the period is 360 or 2 pi. So what we're really doing is, to the first value, add the period, add 360, you're at 395. I'm sorry, you're at 405. Add 360 to this, you're at 495. Add 360 to this, and you are out of the interval. Okay, so that's another way to think about doing these problems. But in this case, because they're nice numbers like 45, you could just kind of keep counting. After 360, it would be this one, and then this one, and then we're too high. Okay? This is one, again, that might be a good idea to graph on the calculator. Graph y equals sine theta. Graph y equals root 2 over 2. And then also graph y equals negative root 2 over 2. And you'll see where all the intersections happen, and then type in on the window, type in the interval 0 to 540, make sure you're in degrees, and you'll see that there are 6 intersections. Okay? You don't have to do that, but that's a good way just to make sure you've gotten all of the all the solutions. The third one, we have cotangent of theta over 2 equals -1. All right? So we already have the cotangent by itself. We just got to ask ourselves, where is cotangent equal to -1? Well, if it's equal to -1, that must be where the cosine and sine were opposites. That happens at 135 and again at 315, or in terms of radians, that's 3 pi over 4. So 3 pi over 4 or 7 pi over 4. So we set this angle theta over 2 equal to 3 pi over 4 and equal to 7 pi over 4. That's one of those problems, right? Where the angle is not just theta, you've got to set it equal to those unit circle values and then solve for theta. Solving this, we get 3 pi over 2. Solving the other one, we get 7 pi over 2. Those are 2 of the solutions. We've got to give all the solutions between 0 and 7 pi, kind of a strange problem. So what we do then is, well, the period of the function, because the b value is 1/2, because it's theta over 2, b is 1/2. So the period is 2 pi divided by 1/2, or 4 pi. Okay? So all we've got to do is add 4 pi to each of the first values that we got. We got theta was, for instance, 3 pi over 2. So adding 4 pi to that, which is 8 pi over 2. Adding 8 pi over 2, we got 11 pi over 2. Now 11 over 2 is 5.5 pi. So we are still on the interval. But if we add 4 pi to 7 pi over 2, we are at 15 pi over 2, which is 7.5 pi, and that's too high. It's more than 7 pi, so we don't include that one. So there's 3 solutions, 3 pi over 2, 7 pi over 2, and 11 pi over 2. All right, and that's that. All right, so hopefully this video answer key was helpful. I will scan this also and put it on the e-board. Have a good day.